Okay, so let's try another problem here. Let's take a look and see what we got. All right, so what do we have here? It looks like we have some kind of a figure with triangle shapes together. Right? So it says in the figure above, if AB equals BD equals DF equals FH equals 1, what is the ratio of the area of trapezoid FHJG to the area of trapezoid BCED, right? So first of all, let's just, the information they're giving you is that this, so this is 1, this is 1, this is 1, and this is 1, right? And then you're trying to find the area, the ratio of the areas of the trapezoids, right? So it would be this trapezoid here, right? And this trapezoid here, right? You want to find the ratio of the areas of these trapezoids, right? And we can see, actually, you see that these are all right angles here, right? So one thing that you should realize with this is that, okay, so we have this triangle thing and you have all these right angles, and what actually is happening is that you have a bunch of similar triangles, right? Because, well, all of these triangles, they all share this angle here, A, and then they all have right angles. So when you have once you have two triangles and if they have two angles that are equal, you know that they're similar, right? So you know that this little triangle is similar to this next triangle here, is similar to this triangle here, is similar to this one there, right? So we want to find the area of trapezoids, but you know what? I know there is a formula for the area of a trapezoid, but you know what? It's might be one of those areas that you might forget. So I might think of like another strategy, which could be like, you could, like, if you wanted to find the area of this trapezoid, you can take this triangle here, this little triangle here, and you could subtract out the little triangle, and that would give you the area of this triangle here, right? So the thing is that, well, one thing that we should realize is that being that these are similar triangles, then you're going to have the sides are going to be proportional, right? So first, let me just try to look at this little part over here, these two triangles here, the little one, and then the one that's like, I guess, well, this is 1 and this is 1, so this is 2. So it's actually, this side is 2 times as long as this side, right? So let me just try to draw this out on the side here, right? So let's draw this. All right. So and you have this, and I know that this is 1 and this is 1, right? So let's imagine, based on proportionality, let's just imagine, let's say if this side was, well, if this is 1, and this is 1, so then this side is 2 times as big as this side. So let's say if this side was 1, right? Then I can say that 2 times 1, so then I can say that this is 2, right? Right, 2 times 1 is 2, right? Like, again, like 2 times this one is 2, right? So what I can do is I can take this bigger triangle, right, the area of that, and I could subtract out the little triangle, right? Now, the area of a triangle, right, the area of a triangle is 1/2 base times height, right? So let me do this bigger triangle. So the first triangle, 1/2, and then the bigger base, 1 plus 1 is 2. So 1/2, 2 times 2, right? If you multiply that out, you actually wind up with an area of 1/2 times 2 is 1, and 1 times, so it's 2, right? So the area of this bigger triangle would be 2, right? Now let's find out the area of this smaller triangle, right? So that would be 1/2. And that would be 1 times 1, right? This is, the base is 1, the height is 1, so 1 times 1. And when you multiply this all out, it's 1/2 times 1 is a half, and a half times 1 is a half, so it's a half, right? So if you wanted to find the area of the trapezoid part, right? This part here, you could subtract 2 minus a half, right? So 2 minus a half, and that's pretty simple, like, right? 2 minus a half would actually be 1 1/2, right? So you get 1 1/2. And I could write that as, I'll just write it as 3 over, right? 2 times 1 is 2 plus 1 is 3. So I'm going to write it as 3 over 2, right? All right, so that's like this. So this little trapezoid here is 3 over 2. So now let's try to figure out this trapezoid over here. So what I'll do is, for this one, what I'll do is I'll just take this whole big triangle here, which would be 1 plus 1 plus 1 is 4. And I'll say, again, I'm going to follow that proportion that I said. So if this was, if let's say this was 1, then this would be 4 times 1. So let me just draw that out here. Let me draw out this other part, this other triangle part, right? So I'll draw it here, right? So, and then inside there you have this 1 plus 1 plus 1 is 3. So this is 3. So then I'll say 3 times 1 is 3. So I'll say that, okay, so what I have is this part will be 3, and this part will be 3. And then this is just adding 1 and adding 1. So this is 4, right? So in other words, so the bigger triangle here is 4, the base is 4, and the height is 4, right? And then the smaller triangle inside there has a base of 3 and a height of 3, right? So again, let's use that formula for triangles, right? So 1/2, right? I'm gonna do the bigger triangle first, right? 1/2, 4 times 4, right? So you wind up getting, well, half of 4 is 2, 2 times 4 is 8, right? So the bigger triangle is 8, right? Now let me just try this 3 by this base of 3 and height of 3 triangle. So again, 1/2, 3 times 3, right? Well, I know 3 times 3 is 9, and half of 9 is 4 1/2. So 4 1/2, right? So if I wanted to find out this part here, the trapezoid in here, I can say 8 minus 4 1/2, right? So 8 minus 4 1/2, right? 8 minus 4 1/2, I guess if you just kind of figure it out, it would actually be, well, 8 minus 4 is 4, and then you take out another half, so you're left with 3 1/2, right? And another way to write that would be 2 times 3 is 6, plus 1 is 7 over 2, right? Okay, so now we have the areas of the two trapezoids, right? So this one right here, this the one that I guess it's BCED, right? And then you have the other one, FHJG, right? So these are the two. So it's the ratio of the area of the FHJG to the area of the trapezoid BCED, right? So it would be 7 over 2 over 3 over 2, right? Right. Well, both the numerator and denominator are divided by 2, so I can just, well, I can just multiply by 2 on the numerator and denominator, so that 2's cancel out, the 2's cancel out, and I'm just left with 7 over 3. So the ratio is D. Ratio is 7 to 3. Okay, so there we go. We got another one done. All right, that is done.